distributive property is a very important property that is used a lot in algebra. And so we're going to spend 2 lessons working on the distributive property. And in this first lesson, we're going to compare it with order of operation and notice how when we solve a problem using order of operations, we'll get the same answer as when we use the distributive property. And that just kind of proves that the distributive property works. So first of all, we're going to solve this problem using order of operations so that we know what answer we need to end up with. So when we're working with order of operations, we know that we do what's in the parentheses first. So I'm just going to rewrite this over here under the order of operations section. So first I'm going to work with what's in the parentheses. So 4 plus 5 is 9, and I still have times 3. 9 times 3 is 27. So we know we should end up with an answer of 27. Now, we're going to solve this problem using the distributive property, and we should end up with the same answer. To do the distributive property, you are going to distribute the number that's on the outside of the parentheses to both numbers that are inside of the parentheses. And what is really important that you make sure of is that you're distributing the outside number to both numbers inside, not just the first one. So here I have 3 times 4. When I distribute it, I'm multiplying because you know that parentheses mean multiply. So 3 times 4 is 12. I'm going to write down 12. And then whatever operation sign was inside of your parentheses, we're going to pull that straight down. It's going to stay the same. Here we have 3 times 5. 3 times 5 is 15. Now I can add these two together and get 12 plus 15, which is 27. And yes, we do end up with the same answer. Now you may be asking, well, why do we have to solve it this way when we can solve with order of operations? And you're right, we can solve this with order of operations. And that's why this first lesson is just kind of proving that the distributive property works. In the next lesson, we're going to be adding variables inside of our parentheses. And if we have a variable, we can't add a variable and a number together, which is when we can't use order of operations. So we need to use the distributive property to be able to solve those kinds of problems. So today is just an introduction to how the distributive property works. We're going to try another one down here. So first we're going to solve it using order of operations, so we know what our answer is going to end up being. So starting in the parentheses, we have 6 minus 2, which is 4. And then we still have 6 times 4, which is 24. So we're going to end up with an answer of 24 this time. So now let's solve this problem using the distributive property. We're going to take the number on the outside and we're going to distribute it to both numbers inside. So here we have 6 times 6, which will be 36. We're going to pull whatever operation sign was in there straight down, so a minus sign. And we have 6 times 2, which is 12. So we're left with 36 minus 12, which is 24. And we do end up with the same answer as if we would have used the order of operations, which is a good thing. That's what we want. Another way that we can use the distributive property is to help us solve problems mentally so that it doesn't take so long to have to solve them. So I can rewrite this problem using the distributive property, or we'll solve it with the distributive property to make it easier to solve, and we can actually do it mentally. And so what we're going to do is we're going to leave the 7 on the outside, but we're going to change 21 into 2 numbers that are really easy to multiply by 7. So I'm going to change 21 into 20 plus 1. 20 plus 1 is 21, so it's the same thing. We're just going to write it that way. Now, if I use the distributive property to solve this problem, it makes it really easy to solve, and I would actually be able to do this in my head. I wouldn't even have to write it down. So again, to use the distributive property, we're going to take the number on the outside and distribute it to both numbers on the inside. So 7 times 20, which is 140. We're going to pull that plus sign straight over, and we have 7 times 1, which is 7. So 140 plus 7 is 147. So I could have actually solved that problem in my head, and I wouldn't have even had to write this down. But using it like this, setting it up and solving it using the distributive property, just makes problems like this a lot easier to solve. The numbers become much more manageable. We'll try this one. 3 We're going to leave that on the outside. We're going to change 59 into two numbers that are easier to multiply by 3. So I'm going to change it into 50. We always do a multiple of 10, and then whatever is left over. Because it's just a one-digit number, those are usually easy for us to multiply. Now I can use the distributive property, or I could just solve this in my head. But I'll write it down so we can see what it looks like. So we're going to take the 3, the number on the outside, and distribute it to both numbers on the inside. So first we have 3 times 50, which is 150. We're going to pull that plus sign straight over, and we have 3 times 9, which is 27. And now we have 150 plus 27, which is 177. So that was a lot easier to solve than if I would do the old-fashioned way, the longhand way of doing 59 times 3. Just makes it a little bit faster. That's another way to do it in your head. The last problem that we're going to look at is just a word problem, because sometimes it's hard to set up word problems because we're not really sure what they're asking or what it should look like. But for this problem, we're going to be solving it using order of operations, and we're going to solve it using the distributive property, again, just to prove that it works both ways. So the problem says you and your 3 friends go to Air Max. A ticket costs $7, and the super cool socks you have to buy cost $2 per person. Write 2 expressions to find your total cost, and then solve both ways. All right, well, first, let's set this up using the distributive property of what that would look like. So on the outside, we're going to figure out, well, how many people are going to Air Max? Well, it's you and 3 friends, so that's a total of 4 people. Now, how much is each person going to have to spend? That's what we're going to put inside of our parentheses. Well, each person is going to have to pay $7 for a ticket plus $2 for socks. So we can figure out the cost for one person and times it by 4. That's one way we can set this one up. Another way we can set it up is looking at how many people we have times how much each ticket is going to cost, which is $7. So 4 people will pay $7 each, plus 4 people will pay $2 each for socks. So we can solve it either way, and we'll get the same answer. Notice how what we have over here is actually what this answer is after the distributive property. 4 times 7 plus 4 times 2. This part over here is just the distributive property after we've distributed that 4. So over here, let's solve it using order of operations, because this will give us our answer using the distributive property. Here we have 7 plus 2 is 9, and 9 times 4 is $36. Over here we can solve it. This is like step 2 using the distributive property. 4 times 7 is 28, plus 4 times 2 is 8. 28 plus 6 is $36. So either way we can solve it, either way we can set it up, and we do end up with $36. So the big idea from this lesson to take away is that the distributive property is another way to solve problems instead of using order of operations. And to use the distributive property, we distribute the number that's on the outside into both numbers that are inside the parentheses. And we always pull our operation sign straight down. We keep that the same.